you're climbing a stair, it takes n steps to reach the top. Each time you either climb 1 or 2 steps, in how many distinct ways you can climb the top. Okay, so the first thing you see here is like a combination of every time you move 1 step, either you take 1 step or 2 steps. So the first thing you'll think is this can be done using recursion, right? So from the first step, you take 1 step and take the second step. So when do you know that it's ending? When you reach the top. So you can go top down approach where you reduce your n until you reach the bottom, right? When you reach the bottom, that's it, you exit. So first thing I can think of is like create metafib. So you know that you need to n-1, you go down, and then you have to have another one, n-2, right? So your exit condition is if n is equal to 0. So if n is equal to 0, so basically return 0. If n is equal to 1, you return 1. So that's like the bottom step. So in this case, what you need to do here is actually add this 2, right? So you can just simply add this 2 to get the position here. So you can just return and let's try it out. Missing return. Okay, sorry, we missed this. Pass this n here. Okay. So this last case is 2. So n-1 is 1, n-1 is 1. So n-2 is 0. So this should be n-2 is 0. So this should be 1. It's possible that it's negative, right? It's possible that it becomes negative. So your check should be if n is less than 0, you return 0. So what if the step is 1? If the step is 1, you'll have a negative in the second parameter. Step is 1, this is 1 plus, then you'll have a negative. So what you need to do is if it's n is already less than 0, return 0 here. Okay, there you go. Let's try submit. Okay, so it's taking like last consecutive input is 44. So what's happening here is it's taking the time limit, right? Exceeded the time limit. So what you need to do is further optimize this. You notice this recursive function, and it's causing like 2 raised to n because this is duplicating what you've been doing here. So you could actually optimize this by storing the value in some variable. So in this case, we'll call it memoization, using memoization. So let's just pass some n here, some n+1. So if memo n is equal to 0, you compute, right? We compute it. What we can do is memo n is equal to here. Else, we just return. So we already have the value for it. Not enough arguments. Okay, sorry, we missed it. There you go. finish it. This is one way of solving this. But what you could actually do is try to optimize this further by using a bottom-up approach. Notice this pattern is actually a Fibonacci sequence, like n minus 1, n minus 2. It's plus. This is like similar to if you solve the Fibonacci sequence, like the Fibonacci sequence is 1 plus 1 plus 2 plus 3 plus 5 plus 8. This is the Fibonacci. It's similar to what you're doing here. So basically, you're just adding n minus 1 minus 2 until you hit the bottom, which is 0. So what you can actually do here is convert this to a iterative function where, yes, you have this for just num1 for num2, right? And num1 is let me just make this a previous name, which is 0. Num2 is equal to 1. So for I is equal to 0, I is less than equal to n, I plus plus. What you can do here is basically compute the sum, which is num1 plus num2, and num2 becomes s, and num1 becomes num2. So then here we return num2. Let's try it out. Just go to, okay, so there should be a parenthesis here. Okay, see, we over compute by 1. Let's start with 1 here. There you go. Submit. Okay, there you go. So this is the iterative solution solving this. So this is actually a Fibonacci sequence. So this is how you solve it. If you like this video, please hit like and subscribe. And any comments below, please drop your comments. And we'll see you again in the next LeetCoding. Thank you for watching.